let us work on LeetCode problem number 152. It's about maximum product subarray. So given an integer array, which is called nums here, we need to find a contiguous non-empty subarray within the array that has the largest product. And then we have to return the product itself. So product is like a multiplications. All the test cases are generated so that the answer will fit a 32-bit integer. So this is a good thing. It means that the normal variable will never be an overflow. So that's the promise that this problem gives to us. That will simplify things because it means we not need to handle overflow, because every variable in a programming actually have a limited number of bytes it can hold. So when you increase it over the maximum capacity that it can, it's actually going to return back to 0. The subarray is a contiguous subsequence of the array. What it means is you can take a subset of this, but everything has to be connected. So for example, we cannot take 2 and minus 2 without taking the 3, because that will make it discontinued, right? In this case, for example, we get these nums. The output is 6, because that will be 2 times 3. That will be the largest product subarray within this example. Another example is this: minus 2, 0, minus 1. The output is 0 because any other things will result it in negative. So 0 is better than negative. Okay. And then this is the constraints, whereas it could be very large numbers of membership inside the nums, while the integer itself, the value is limited from minus 10 to 10. So there will be minus, 0, and 10. And then this is the guaranteed just now, which is about that it always going to be capable to be contained by a normal variable, so we don't need to handle the overflow. Now let us start to talk about solutions. So to think about the solutions, sometimes what we need to do is we need to run it manually and try to find pattern out of it. For example, in this case, a product for example, a simple one, a product of all positive number will always be to take it all, right? Because what? Because the content of the nums will always be an integer. There won't be a fraction. So if it is an integer and if it is positive, definitely when you multiply it, you will always get a bigger result. So when everything is positive, the largest result will be by taking everything, right? Now, another thing that we should be noticed and be thankful about, that they give us these examples. This is a good examples, because another behavior, characteristic of a multiplication is whatever is being multiplied by 0 will always be resulted in 0, right? That's why in this case, for example, if it is a positive number, the largest definitely something that is not contained within 0, right? So we actually have to eliminate 0 and then compare the other two sides of it. Why? Because we always have to return a contiguous number. So 0 cannot be contained in anything because 0 will always make it become 0. So in other words, this is like separating the array into two subarray of possibilities. And these two subarray cannot be connected at all because of the 0. And because of the requirement that it should be contiguous. That's why from this, we can understand that if we find a 0, we have to separate it into multiple problems of similar nature, right? Now, from this example, we also notice another characteristic we need to get out of the zero, that if everything else, in this case, if you see the other subset of the array will actually give us the bigger number because they are positive. But what if everything is negative? If everything is negative, definitely 0 will be the biggest one, right? Okay, so remember that two characteristics of 0. Now, what we need to do also is to consider what does negative numbers actually uh, make what is the characteristic when we try to handle negative number. Let's try it. Let's try to see it. If it is a single one, definitely it is by itself, right? There is no 0. If there is 0, remember, and the other one is negative, of course is 0. And then when there are 2, in this case, the largest number will be 3, correct? 6, which is minus 2 times minus 3. So it will be 6. Now, let's increase again. We haven't found a good pattern here that can help us to solve. That's for let's dig it deeper. From this one, we know that if we multiply everything, it becomes minus 24, right? Definitely that is the lowest. While in this case, the biggest will be if we take this one. Another option is take this one. This one is 6, while this one is 12. And 12 is bigger than 6. So it becomes 12. That's the bigger one. Now let's go at it again. What about this one? This one will give us, because this one, if you notice, if we multiply everything, it becomes positive, right? So this will be actually multiplying everything. Minus 2 times minus 3 times minus 4 times minus 5, which is, how much was it? 6, 24, 120. 120. Now, from here on, we can felt there is some pattern there, right? For example, when it goes to this, it actually taking minus 2 times minus 3. But when it goes to this, there are what you call it, 3 numbers of it. It will only take this one, right? When it comes back to here, it take everything again, like this one. Then maybe let us get in one more to confirm this kind of, you see, an interchange pattern being shown up. So if there is this thing, what is the result? So the biggest will be this, correct? Because this will be 4. An even number of negative will be positive. This will be the biggest one. So it's actually this times minus 6, which means 30 times 12. That will be 720. So when it goes into odd numbers, it will take only the up to the last few. So it will take not, it will skip the previous one, right? So from here, what we can see is there is these things. There are 2 things that we need to keep on, right? Because whenever it goes into positive even numbers, we will always need to get all. It's actually taking all the largest values. It will take everything, right? It means that it will take everything. While when it is not, it is odd, it will only take everything except the previous one. So what we need to handle here is actually that we need to keep two kinds of values. One is when we multiply everything, because somehow, for example, in this case, although the maximum is when we don't take everything, but we always need to get the one that is taking everything later on. You see? Here will come here. To make it more clear, if we try to add another one here, -7, the largest will be is multiplied by 6 and of course multiplied by -7, which is taking everything from here. Although, right, wait, 1, 2, 3, 4, which means it will be taking everything from here. You see? So one thing is we need to keep on collecting the total multiplication, because in the next iterations it won't be used in this one, it won't make the maximum for this one, but it will make the maximum into this one. So that's one of the things we need to track. Another thing we need to track is actually when there is the second one, which is just the -3. For example, this case, when it is just the -3, it becomes the next combinations, and then from the next one it becomes -3 to the 5. That become the next things to be used as the maximum. So that's those the two things, right? So what are actually the second part? Because the first part is pretty easy to understand, that we need to keep track the total multiplication. The second part is a little bit challenging to understand, to get a pattern. Basically what it means is that we need to also keep a track of the negative values that contain the last number. Actually, that's what it means. Why? Because if you notice, the thing is we need to get contiguous array. So the previous values still need to be intact. Now, the interchanging of the signs means that at the next levels, when it meets another negative, it becomes a positive, and so on. So when the sign is changed, it's actually representing the other side of possibilities, where the other side of possibilities will come in play when it meets another negative. So what it means is, during this iteration, there is only one negative, right? So in other words, if we try to keep track the points at the first iterations in this problem, we only can keep track the negative values, while the positive we don't have. Now, at the second iteration, we now have two possibilities. One is becoming positive, which is when we multiply everything, right? So that will be 6. -2 times -3, that will be 6. Now, another thing is, what is there a possibility to start getting a different sign which contain the last number, which it is if we take the -3 by itself. This is the very first venture of this iteration to be in a negative values, right? Why don't we take -2, for example? Because that's useless. The problem asking for a contiguous subarray. and -2 cannot be the contiguous subarray. Okay, because at the next iteration it will have to be bounded with the -3, not the -2. So the -2 cannot do anything further other than this multiplication with -3. But do we skip the -2? No, we didn't, because in the previous iteration we have considered -2 as a negative value by itself. So that's the key point here. So it's basically tracking when it's starting to have a different sign. So that is become the different possibilities, right? Now comes into the next things. It become what we track is the -4 combining with this. Basically, the 6 times -4 is when we multiply everything, right? That's become -24. While the -3 times -4 becomes the 12. So this is the positive number that is contiguous, that is possible in this one. And let's do further these numbers. Now there is -5 combining with this. If we multiply the -4 and the 24, it becomes the 120, which is the largest number at this stage. And then the rest is the negative part. The largest negative, the lowest negative is when this 3 comes in, which is the 12 times -5, right? That will be the -60, right? And then how about the next iterations? The next iteration, if you see now, the -60 become the biggest part, because now we need to multiply it with -6. Become -720 and 360. Oh, right, this is wrong answer. This should be 360, right? 3, 12, 60 times 6, yes, 360. So if you see now, at this point, 120 comes from this. Well, at this point, the 360 comes when multiplied by this. That's the reason why we need to always skip these two, because at each iteration, it have an interchange, what you call it, interchange roles. Okay, so that's about it. That's how we actually going to solve this, by using all this pattern that we made. So in total, we have 3 patterns actually, because the positive and negative actually are the same. The positive pattern is actually a sub-pattern of the negative. The way we solve this, let's try to run the same logic. Okay, 2 and 9. The positive is there is not yet anything negative. When we put 2, 3, it becomes 2 times 3, 6, and there is still nothing about negative value to be tracked. While it is 4, it becomes the 24, the 12, none. Okay, so that's about it. And another proof is if we try to make it into negative, for example, this will work. That logic will work, because basically we keep it, right? Let's try this. 2, of course, is 2 and none, while 2 and -3 becomes -6, and then this is the, and is there anything about the positive we can track that is including the -3? Nothing, so none. How about 2, -3, and 4? Now 4 times -6 becomes -24, right? So this is the negative, while the positive will be if we take 4 by itself. This is the starting point of having the positive. And then from this, of course, the biggest will be 4. This, the biggest, well, the biggest will be still 2, which is from here on. And then let's say just give another number 5. 2 minus 3, 4, 5. Does the logic still works? Minus 24 times 5 is 100 minus 120, while the other one is 5 times 4, 20, correct? That 20 is the largest subarray, so it works. This proves that this actually and this two prove that the positive logic is actually a subset of logic for the pattern that we found when we playing around with the negative. So the essence here, we need to keep track these two numbers, the negative and the positive. Okay, and then another pattern is the 0. When it's a 0, we have to divide it by 2. Another thing is if everything is negative but there is a 0, the solution always is a 0. So from this on, first is we need to separate to take care of the 0 so that we can get all non-zero subarray, contiguous subarray, and then for each contiguous subarray that is separated by the 0, we run this logic. Okay, this logic. After that, at the end of the things, we check what is the result. If the result is negative, it is indications of everything else other than the 0 were a negative number. In that case, the biggest solution, definitely, the biggest product definitely is 0. Okay, so let's take care about the 0 first. So separates is actually, what you call that? An array, okay? And then for its member in the nums, we shall compare it. If it is 0, what we are going to do is we're going to create a new subarray. Otherwise, we just need to append it to the latest one. In this, with this logic, we're also going to get rid of the zeros. And remember, after that, after the separation, we need to run this for each of the separation. Okay, run the next logic for each separates. But at the end, we need to check for negative and 0. Basically, this is these things. When everything is negative, meanings, but there is a 0, we need to find the 0. We need to make it to return 0. So what happened here is if max product is negative and separates has more than one member. If it has more than one member, it means we find a 0 because it only increasing its subarray whenever it finds 0. That's how we detect if there is a 0 without doing another loop or without storing another flag. If it is max product is less than 0, and we also need to check if max product is not none, because in Python you cannot compare none with integer. We need to return the 0, else we return the max product. Okay, so now let's implement so we already handled this and this. Now we'll handle the implementations of this. Okay, so remember that we need to take care of this negative positive numbers. Okay, It is good as long as we store the negative and positive. So we store two different signs. We don't need to care about whether it is in what specific order. So in this case, I will always initialize a value for the first one. But it separates. For as in separates, that's basically for each separates, we run the logic. So we'll initialize it like this. So if you notice, we always initialize it for this problem. To make it clear, we initialize it by this one, and the other one is none. Okay. And then in this case, the max product, of course, always be as 0. And then after that, we will loop in towards the end of S. The way to loop in the S0, the PN set 0, will always be updated simply by just multiplying it with the new number. Now the tricky part, if you remember, it's about the none. When does the none change into number? It changes into number when it detects that it can create a different sign compared to the other one, right? But with the condition, it takes the last number because we have to keep the continuity of the subarray. So in this case, we need to be able to compare the sign. So let's make a helper functions to help us with that. Else 1. So in this case, I'm ignoring the possibility of value 0 because we already eliminate all 0 members here. That's why I can simplify the get sign, which is going to be used here later on. That if it is less than 0, it will be -1, else is 1. Basically, just representing negative, positive sign. So, if pn set 1 is none, right, then we need to check if get sign of si is actually if get sign of I is actually what do you call it, different with get sign of the pn set 0. So basically, when we start to be able to have a different sign, this is the pn set 0, right? And it will always start by only having the last number. Even if when we try the positive, as you see here, it starts only with this one. Why? Because definitely it cannot get the other one. Otherwise, it becomes a negative. This is when pn set 1 have its initial number. Otherwise, if pn set is no longer 1, it's actually just following the same logic as pn set 0. Just multiply it. Which color is red? If you notice, after we have initialization, the logic to maintain this is very simple. Just multiply it with the latest number, right? And for each of these, whenever we finish getting the new set by calculating, evaluating the effect from this, we try to check for the max product. So, of course, for this, we need to be careful because everything here can be none. So let's make another helper function to help us compare maximum by considering that if it is a none. Basically, If v1 is none, just return the v2. If v2 is none, just return the v1. Otherwise, it means both of them are not none, then we can use the Python max function as it is. So get max, what we need to get max here is the max product, get max product, and then get max the pn set 0, pn set 1. Right, actually this one we also need to use the get max because this is looping for its s, right? So it is actually this line going to be executed multiple times if there is a 0 that's separating everything. So we need to do this. So here is how we solve the problem. From this, we already covered all of this pattern. Just now, we just implement this pattern. The first of all, we implement this, and finally, we embed this logic. Right? So this is the 0 when we separate. This is the positive and negative without 0 logic. And this is the 0 when everything is negative. Okay, another thing I need to do is I need to clean up what the previous code that actually I'm preparing but I didn't use because I rewrote it again during this video. So let me clean this up. Now what we need to do is we need to check if this is actually working. Let's run the code. If there is any bug, it's accepted. We can use this use test sample case. Let's check. So at least there are 2 test cases to check. It looks good so far. Let's submit it. And that was the one that, oh, it's least out of range. Pn set. Because S could be empty. If S is empty, when it is less than, sorry, if it is equal to 0, we skip it. Why it can be empty? It's because I initialize everything with this, right? Can I close this first? Oh no. Yeah. Basically, I initialize it with this. Imagine if the first member of nums is 0. It means I directly appended another empty. So what happened is it becomes this, correct? If the very first of the nums is 0. That's why there is a possibility that this is empty. Actually, if it is another 0 again, it becomes this again. Okay? So that's what makes it troublesome. And we have to handle it. Now, that says if max product is none, actually we have to handle it too, because if max product is none, it could be that everything is 0 values. If everything is 0 values, so all the S will be 0, so we don't actually run anything, then the max product will be kept in none. So if this is not fulfilled, it means for a max product can be none. Right? If max product is none and len separates is more than 1, actually we have to return 0 too. You see, this is when everything is actually containing 0. This is where it will come, because when everything is 0, the largest of course 0, not none. So we have to return 0 there. Let's run the sample case first, just in case I make some bugs. Seems like not. Let's submit it. See, yep, it's faster 94% of the Python 3 submission. Cool. So that's it. That's how we solve this problem. So to summarize, basically what we did here actually, we need to find pattern by playing around with some examples. Possible examples coming from the constraint. What are the possible input that could be? And then from there, we try to classify the input, and then we try to find a pattern. So we find 3 patterns here. The positive, negative, without zero, those are one pattern. The zero itself creating 2 patterns, the separation pattern and the zero as an answer pattern. That's how we handle it. This is the handling of the zero as separation pattern. This is the handling of the positive and negative without zero values, which is basically maintaining these 2 numbers, the positive and the negative. Though in this case, I don't really make it such that the zero always been positive, this one always been negative, because it always interchanges whenever it increasing. But basically these two have to be kept in different sign. The last pattern is about when zero is actually the answer. So that's it for today. Thank you for watching. Hopefully this is helpful. Bye.